Is Chapter 5, Section 2, Rates. Rates are a type of ratio. We learned about ratios in Section 1, and this is just an extension of that. A rate is the comparison of two different quantities. The different is added to our definition here. This is an example of that, 270 miles per 13 gallons of gas. Or I have a ratio of 270 miles to 13 gallons of gas. In this case, our numerator is miles and our denominator is gallons, and we can tell those are different quantities. They're not the same they're not the same units. So again, we can say this is 270 miles per 13 gallons of gas. I can say I drove 270 miles for 13 gallons of gas, and so on. That's the way we look at this kind of a rate. Now this one is one that's very familiar to us, as most of us have jobs or have had jobs that pay us in dollars per hour. And so $8.25 per hour, the fraction bar here, we know that to mean also division, but in this case we use the word per or for. There's a few others that we'll get to in a minute, but $8.25 per hour that I work is what my pay is. And again, just with ratios, you can write these as A to B with the colon, or A to B as a fraction. Generally, with rates, we write them as fractions, and we look at them in the fractional form. So here again are some words that imply we're talking about rates. If you have the word per in something, for instance, a certain number of miles per hour. For is another one, dollars for a particular amount of, say, produce or meat comes like that, dollars per pound, or I get, a certain number of pounds for a certain number of dollars. In is another one. We can run so many feet in a certain amount of time, seconds. Feet in particular amount of seconds is one way of implying you have a rate. And on is another one, miles on gallons. So I drove the 160 miles on 13 gallons of gas. Those are all different ways of saying something that implies we have a rate. Anytime you have speed, miles per hour, feet per second, or same with metric, kilometers per hour, or meters per second, then you're talking about a rate. So let's look at an example here. In this case, I drove my car 160 miles on 6 gallons of gas. So the rate here is 160 miles on 6 gallons of gas. We can write this as a fraction, as you see, and we always want to make sure that our fraction is in lowest terms. So we're looking for common factors in our numerator and in our denominator. So in this case, I can rewrite 160 miles as 2 miles multiplied by 80, and that's 2 times 80 is the same as 160, and we can rewrite 6 as 2 times 3, and then we can see that common factor, the 2 in the numerator and the 2 in the denominator, and they cancel or make a 1, in which case we can just cross them off. So we have left 80 miles per 3 gallons of gas. Now, this isn't always a convenient way to leave your rate. Sometimes when we're talking to our friends and we would say something like, I get 80 miles per 3 gallons of gas. It's not a familiar way. They don't understand necessarily, is that a good or a bad rate? And so that lends itself to something called unit rates. And what unit rates are rates that have a denominator of 1 unit. This is the so-called unit rate. So to find a unit rate, we divide the numerator by the denominator. You maybe remember that a fraction, A over B, we have that as, we know that to mean also division. So A over B is the same as A divided by B, or in this case, it's the same words, but just a different written way. we would A divided by B, and we can use long division to solve that. So if we go back and look at the problem we just solved, okay, so we have a rate of 160 miles for 6 gallons of gas. What if I wanted to know for 1 gallon of gas? Well, the way we go about doing this is we divide our numerator by our denominator. So let's pull up our calculator and take a look at how we would solve this. So here we have 160, and we're going to divide that by 6 gallons. All right, that gives me 2 and 26 and 6 repeating. We can see that. So this equals 26 and 6 repeating. Well, we really don't need to know it out that far, so I'm just going to round this, and we know that that to be about the same, approximately equal to 26.7 miles per gallon. Now, do you think it would be any different if we looked at the 80 miles divided by the 3 gallons of gas? It shouldn't be, but let's just check and make sure. Here's our calculator, and we type in 80 divided by 3, and that would equal, again, we see the same 26.6 repeating, and we can round that to this place. We know that if we're looking at the 10th place here, we look next door, we see that that 6 next door is more than 5, and so we add 1 to the 6 here, so we get 7, and we lop off the rest. So in this case, my car gets 26.7 miles to the gallon, and that makes more sense to us. And we can say, hey, that's pretty good actually for a rate. So that is why we look at unit rates. Another unit rate that is common for us to look at is unit costs or unit prices. And this is just the cost for 1 unit. We use the unit cost to compare different products to determine which is the best buy, which is more economical for us. So here's an example that we're going to look at right now. Which soda is a better deal? Is it better for me to spend $1.99 for a 2-liter bottle of soda, or $3.99 for a 12-pack of soda? A 12-pack is 12 cans, and each can has 355 thousandths of a liter. If I multiply 12 cans by 355 thousandths of a liter, I get that there are 4 and 26 hundredths of a liter in a 12-pack of soda. Okay, so which is the better deal? Well, let's look at the unit cost. So first of all, our first option here, we had $1.99 for 2 liters. So let's write that as a ratio, $1.99 per 2 liters. All right, and now we want it to be a unit rate, and so in this case we go $1.99, and we're going to divide that by 2. Remembering that we bring our decimal straight up, we know that 2 doesn't go into 1, so we're looking at 2 into 19. Well, that would be 9 times. 9 times 2 is 18. I subtract, I get 1, I bring down my 9, and 2 goes into 19, again 9 times, that's 18. I subtract and I get 1. I'll bring down another 0, and I have 10. 2 into 10 is 5. 5 times 2 is 10, and I can subtract to have a 0 there. So I know that the unit cost is a 995 thousandths of a dollar, which is 99.5 cents per liter. For every liter, that's the cost when you have a 2-liter bottle. Okay, so our second choice was $3.99 for a 12-pack, which is 4.26 liters. This is $3.99 for 4.26 liters. And we're going to divide here. And again, we could do this out longhand, but we could also look at this with our calculator. Just move this over here. So the way we do that, $3.99 divided by $4.26. And that gives me a long decimal number. But this one we had into 3 decimal places. So let's look at this one also to 3 decimal places. So what do we have here? We have, this is 9.936. And we want to round to this 6th place here. We look to the next one right here, and that is also a 6. And so we know that we have to add 1. So this is 0.3937, and that is dollars per liter. So which is the better deal in this case? In this case, this is the less cost, which is the soda in the can. So 12-pack of soda is actually cheaper than the 2-liter bottle. Now again, $3.99 is a good price for that. It isn't always that cheap, but in this case, in this particular example, at this particular store, the 12-pack was the better deal.